explaining inverse square law, direct square law, the law of reciprocity, and 15% rule. Inverse square law is the relationship between the radiographic density and the SID and how it is inversely proportional to the square of the distance. Therefore, with inverse square law, as the distance increases, the radiographic density decreases. In order to compensate for that, we have to increase the MAS. This is the formula used for inverse square law. It is intensity number 1 over intensity number 2 is equal to the distance 2 over the distance 1 squared. So we have an example that states a radiographic exposure of the chest was taken at a distance of 72 inches using 10 MAS and had an exposure of 50 MR. What would the exposure be at a distance of 80 inches? So we're gonna find out what is the key word and what they're asking us in this problem. So basically they're saying here, what would the exposure be at a distance of 80 inches? So the key word here would be exposure. So now we're gonna see what formula we're gonna use. We know that exposure has to do with intensity. So right there we know that this is gonna be the inverse square law. So I'm gonna go ahead and write down the inverse square law formula, which is I1 over I2 is equal to D2 over D1 squared. Now I'm gonna go ahead and plug everything in. So 72 inches, this is gonna be distance 1. Using 10 MAS. 10 MAS, we don't need that. We don't need that in this problem. And had an exposure of 50 MR. This is gonna be the intensity number 1. What would the exposure be at a distance of 80 inches? This is gonna be our distance 2, so we do not know what intensity 2 is. So we're gonna go ahead and plug everything in. So 50 MR is gonna be intensity 1. Intensity 2, we don't know. Distance 2 is 80. And distance 1 is 72 squared. So I'd like to first find the squaring part. So 80 times 80, 6,400 over 72 times 72, 5,184 is equal to 50 over x. So now we're going to go ahead and cross multiply 50 times 5,184. That gives us this big number is equal to 6,400x. Now we're going to go ahead and put x all by itself. So we're going to go ahead and divide by the same number and divide this by 6,400. That gives us 40.5 MR is equal to x. So keep in mind that some questions are going to ask us to round it. Also, it's good to always put the unit. And this is basically how it will be done. Direct square law is used to maintain the MAS. This is the formula used for direct square law. It is MAS number 1 over MAS number 2 is equal to distance 1 over distance 2 squared. So we have an example here that states a radiograph of an AP knee produced 100 MR of exposure, 170 kVp, and 10 MAS was used at 40 inches. What new MAS would be required at a distance of 60 inches to maintain the density? So first we're going to go ahead and see what they're asking us here. So they're saying to maintain the density. Also, new MAS. Right then and there, we know that the only formula that has to do with maintaining the density is direct square law. So we're going to go ahead and write down the formula, which is MAS1 over MAS2 is equal to distance 1 over distance 2 squared. Now we're going to go ahead and plug in the numbers that they're giving us into the formula. So they're saying here 100 MR of exposure. We don't really need that. That's good to know. We don't need 70 kVp. We also don't need kVp. And 10 MAS. 10 MAS is going to be our MAS number 1. Was used at 40 inches. 40 inches is going to be our distance 1. And then it's saying here at a distance of 60. 60 is going to be our distance 2. So what we do not know here is our MAS2. That's what we're going to find out. So our MAS1 is equal to 10. Our MAS2, we don't know. Our distance 1 is 40. and our distance to is 60 squared. I like to do the squaring part. So 40 times 40 is 1,600 over 60 times 60. 3,600 is equal to 10 over x. Now we're gonna go and cross multiply. So we're gonna cross multiply 10 times 3,600. That gives us 36,000 is equal to 1,600x. So in order to leave x by itself, we have to divide by the same number. Cancel out. Divide 36,000 by 1,600. That gives us 22.5 MAS. This is our answer. Keep in mind that most of the time they're going to tell us to round. So if they do say that, we'll round it to maybe 23 MAS. And also write always the unit, okay, so nobody gets confused. The reciprocity law is a law that is used to maintain the same exposure even though the factors change. This image will help in explaining reciprocity law. The formula used for reciprocity law is MA is equal to MAS over second. Basically, what we're trying to prove here is how using the same MAS for both images but changing MA and second will still provide us with the same radiographic density. For example, on the image to the left, which is the original image, I use 68 kVp, 12.5 MAS, 50 small focal spot MA, and 1/4 of a second to achieve this density. In order to maintain the same density on my image to the right, I used 68 kVp, 12.5 MAS, 300 large focal spot MA, and 1/4 of a second. Although both images are supposed to look identical, the original image, which is the one on the left, has a better resolution because of the small focal spot size. A small focal spot size is best for the image because it provides better recorded detail, but not the best for the equipment if being overused. For a 15% rule, basically all we need to change the radiographic density of an image is either increase 15% or decrease 15%. The complete definition of the 15% rule is that as the kVp increases 15%, the radiographic density is going to be 100 or doubled. And as the kVp decreases 15%, the radiographic density is going to be 50% or half. kVp can also be maintained. There's other words that can be used as maintained, such as satisfactory, sufficient, good, optimal. All those words mean the same. And when we maintain the 15% rule, what happens is that the kVp increases 15%, then our MAS is going to be decreased 50%. And if our kVp decreases 15%, then our MAS is going to be multiplied by the factor of 2. There's another term also that we use with the 15% rule, which is called double optimal density. What happens here is that 15% of the kVp is going to be increased, therefore our MAS is going to stay original. Or the kVp could be original and then our MAS is going to be doubled, and that will be the double optimal density. These three images will help explain the 15% rule. Notice how the image all the way to the right is the original. On the original image, the technique used was 50 kVp and 1.7 MAS. The image in the middle, the kVp used was increased 15%, giving us a technique of 58 kVp and 1.7 MAS. Notice how much radiographic density is on this particular image. Reason why is because when kVp increases 15%, the radiographic density is 100% or double. The image all the way to the left, the kVp was decreased 15%, giving us a technique of 42 kVp and 1.7 MAS. Notice how much contrast increased significantly and how the radiographic density decreased. The reason why is because when kVp decreased 15%, the radiographic density is 50% or half. In conclusion, the MAS never changed for either images. Only the kVp increased or decreased 15%. Therefore, a 15% of the KDP is all we need to make a significant radiographic density change to our image.